I hope everybody can hear me fine. Before I start, I just kind of want to get a feel of Suricata exposure, and so if you guys don't mind scanning that QR code, it will take you to a link. There's no registration. It's not a phishing attempt, but if you could just make up to 2 choices. Just kind of want to, see what your exposure is. So we'll take a moment. All right, and if somebody's already finished, just raise their hand. All right. First spooner, here you go.
I mean, it was just one question, right?
That's perfect though. There you go.
Okay.
You're welcome.
Excuse me, sir. Is this a Jared Doggy?
No.
No. Thank you, sir.
Track 3. Okay. All right. So we've got a good number of you haven't heard of Suricata. Well, I'm going to talk about our latest release, so that's good. And some of you have heard and want to learn more, and we'll certainly do that. And a couple of you are actively using Suricata, so that's great. Thank you. All right, I'm going to switch right over to the presentation as soon as I can figure out how to do that. Okay. In this presentation, I'm going to talk about. All right. I'm going to talk about our newest release, Suricata 8. Suricata has been around since before 2010, 2008, I think. This release represents a significant milestone for us, and I'll talk about that in a little bit. But like all of our releases, it's been a heavy collaborative effort between the folks at OISF and our vibrant user community. So we are quite thankful to them for the contributions they have made, and I'll talk about those a little more as we proceed. I wanted to bring up a little bit of trivia, and I wanted to ask this question. Does anybody know why we have these mercats all over the place in our branding, in our logo?
Always on alert?
Very good, very good. Yes. Can you pass that to him? And over here?
It's the genus name for meerkats, Suricata.
Yes, indeed. Here you go.
Thank you.
Yeah, so Suricata is the genus name of the mercat. The mercats are known for their diligence in watching over their mob. A mob is a group of mercats. So that's where the title comes from, and I just wanted to pass that on. So the mercat is key. You'll see that all over our branding, and almost everywhere you see the word Suricata. So Suricata, like I said, is a big achievement for us, and we remain committed to maintaining Suricata's position as a leading, relevant, and trusted open source network detection tool for the community. So we realize that Suricata is used in a lot of places. Some are mission critical, some are highly sensitive, and we take that role very seriously as we put together changes for it. I'm going to talk again about what's new in Suricata 8. Before I go on, just a little bit about me. I've been with the OISF organization for 6+ years. I was fortunate enough to join in 2019, and I've been quite happy. I had never done open source work before, but doing this type of open source work was something I didn't realize I really loved. Not only do I enjoy the technical parts of it, but interacting with the community all over the world, really, and making a difference. So I've worked with vendors, I've worked with users from throughout the globe, which has really been satisfying. I'm also sorry, I left off the second part. I'm also an employee of CoreLight. where I oversee Suricata deployment on all our physical sensors and virtual sensors. I also do performance engineering there. In case you're wondering, how much traffic can Suricata handle? I've seen it go anywhere from a couple of 100 megabits per second, firsthand, all the way to 200 plus gigabits per second. So Suricata can scale with appropriate hardware. But if you're playing in the 200 plus game, you already know what appropriate hardware means, and it can do it, and firsthand knowledge of that. Okay, I'm going to briefly talk about OISF, the foundation, and this is important because this is what sets Suricata in the open source community, and this is what will keep it in the open source community. So it's a nonprofit that was set up to oversee Suricata development, to keep it open, to prevent it from being commercialized like some other solutions out there. The foundation relies heavily on contributions from organizations throughout the world, and we have a healthy list of consortium members that provide the funding for Suricata's development. The link I realize you can't click on, but it's oisf.net. You can learn more about the organization, about the people that are involved, about our consortium members, and there's ways that if you want to become involved, you can. All right, so Suricata 8 was a long road for us. A little bit of backstory, and then I'll jump back into it. Suricata 8, 8th major release, which is the obvious part. The other part that we are really proud of, which I will talk about, prior to Suricata 7, we tried to get major releases out on a regular cadence, and we failed. And we failed and failed and failed. And then COVID came along, and we decided not to do a major release while the world was not correct. And we extended the lifetime of Suricata 6, but we vowed to become more regular in our releases. So starting with Suricata 7, we decided that every 2 years, we're going to do a release. Every 3 years, we would end of support the previous release. So at any point in time, we have a major release, which is supported for 2 years. Which comes out every 2 years, and then the previous release is for 3 years. So obviously, there's a year overlap, and it's during that year of overlap that we are available to help folks migrate from the previous release to the current release. But once that period ends, we will still answer questions, but there'll be, you really should update. Because along the way, we put in security fixes and bug fixes. Security fixes really are that important. And so we'll still try and answer the question for older releases. Suricata 8 came out in July of 2025. It will be supported till July of 2028. Suricata 7 came out in 2023, and it will be supported until July of next year. So that's heads up. Everybody gets a year to move forward. And like I said, we are here and can help. We have an active forum and Discord channel where we'll take questions. In Suricata 8, a lot changed. There's some numbers up there, but one of the things that we are most excited about is we came out on time. We said it will be July of 2025, and for an open source organization where financial motives are not the reason for our existence, nor do they drive our development. We do it based on community support and what we think the community needs. That's quite an accomplishment to get it on time. The other thing that's really exciting is if you look at Rust and C, how many of you know the Rust language or know what it is? 1, 2, maybe, okay. Those of you who have used Rust know that it has a lot of advantages over C. Not only is it incredibly fast, but it's incredibly hardened. It can be hardened. So we use it for parsing untrusted data, that is stuff that comes off the network, stuff that comes out of files, and we are shifting the balance of our code from C to Rust, and we had major movement in this release. We're about 75%, 25%, 75% being C. The release, again, I realize you can't click on the link. Suricata.io is the landing page for all things Suricata related. You go to suricata.io, you can get to our forum, you can get to our community resources, you can get to anything that's related to us, including things that are special for us, Suricon, our annual users conference, and then there's a lot of links to various things that could be helpful. One of the things that sets this project apart is that we do have a vibrant user community, and they do make lots of contributions. So I'm not going to talk about the individual scores that you see in this, but we maintain a leaderboard, which is meant to be a lighthearted way of just showing, contributions and where they come from. It's not meant to pit one against another, but it's just meant to show you that organizations have an impact on Suricata. And this shows you the top 10. Stamus Networks is particularly important to us because they do provide a bulk of the contributions from outside from the community. And several of the folks on their staff are also heavily involved with Suricata from its early days and remain so. So this is the organization level, and this is at the individual level. Eric LeBlond was associated with Suricata almost from the start, and now he's CTO of Stamus Networks. So it's not surprising that they take the top 2 spots. One of the things I wanted to highlight on this slide is the person at number 3, Elise. For the past several years, the OISF has worked with Outreachy, which is an organization dedicated to help underrepresented folks get into security or cybersecurity and technical fields. And it works through, there's a vetting process, there's a selection process, and then there's an intern process. The intern is a paid 3-month agreement. We have 2 folks on staff from Outreachy. They're both working out wonderfully. Elise was an intern from the previous session, which started a year ago in December. And during that 3-month period, she made a lot of contributions. So I wanted to highlight Outreachy for a couple reasons. We think it's great. And if your organization or who you work with can possibly work with Outreachy to maybe help some other folks, I think that would be great. Outreachy.org is where you can get started and look at it. It's an involved process, but it's also can be a beneficial process to everybody. Okay, so for those of you that don't know what Suricata is, this picture kind of depicts how Suricata fits into most environments. This is your classic, internet firewall intranet picture. Suricata usually runs in a position in your network where it has visibility to the things that you want to protect. In a large organization, this picture is going to be repeated a lot of times because the sheer volume of traffic and the way that your network is organized is going to be different if you're a Fortune 500 versus a small medium business versus something else. So Suricata in this case is hooked up to the router switch that has visibility to the intranet over a tap. So in this case, Suricata would be operating in passive mode. It's receiving all the traffic, but it can't affect the traffic flow at all. This is a north-south deployment of Suricata, meaning it's watching traffic between the internet and the intranet. A lot of large organizations that I'm familiar with also have many deployments in their intranet where they're watching east-west traffic, so traffic that stays solely within it. Suricata can do both at the same time. But depending on the size of what's to the right, you may want to have multiple instances of it and then collect the data upstream. So those of you who are using Suricata, how many of you are using it in an east-west scenario? Okay, and what about north-south? Okay, very good. Suricata 8 brings a new mode, so that firewall block can now be replaced with Suricata. So you can run Suricata in inline mode as a firewall. It can do both. It operates as a classic firewall that is accept nothing except what's permitted, which is exactly what you want. And then you can also apply detection rules. So if your hardware is capable and you set things up right, you can buy it with one appliance. And one of our consortium members, whom I can name, is actively using it as their network firewall. And even though AWS had a little bit of tarnish last week, most of the time that doesn't happen. But they found success with it. All right. So I'm going to go over some of the new features and then dive a little bit deeper on some of those. So Ari talked about Rust. We've expanded the scope of Rust, the usage of Rust. We've converted some major components within Suricata that were C-based into Rust. That one was particularly interesting because it was a module that was doing all the HTTP protocol parsing. Those of you who know the protocol know it's not easy. It's very involved, but it's also critical that it be hardened and that it be efficient and that it be complete. So that effort was led by a community member of ours from our neighbors to the north, with some assistance from some folks on the OISF staff. Protocols, in the Suricata rule language, everything is protocol driven. So you have a rule and you say, what does this rule apply to? The first thing that you specify is what protocol does it apply to, and that's an application layer protocol like SIP, or it could be something low level like IP or ICMP. We added 8 new application layer protocols this time around. I'll go over those later. One of the things that is important to know about Suricata is not only can it do detections really well, but it can also be a logging, a network security monitor. So it can generate lots of metadata. So some of these new protocols, you only provide metadata for forensic purposes. Some of them also do logging, and you can do detection on it. So detection means, can I write a rule that uses that protocol to trigger alert, and logging is just, I'm parsing the protocol and I'm writing all this stuff out so you can see what's going on in your network. Lua is really important. I was talking with somebody earlier who asked me, is Lua there? Or why aren't we using Lua more? Lua is a programming language that we make available to our rule writers. So not only can you use the keywords that we provide as part of the rule language, but you can also put a program in there. And the program, the Lua script, it's very Pythonic in some ways and its own thing in other ways, can determine whether or not an alert should trigger using whatever dynamic heuristics that they want to do. So we make everything available within Suricata, available to the Lua script so they can check the values of various things. But we also allow them to decide what triggers an alert versus what doesn't trigger alert. So it can be dynamic if you want, or it can be more old-fashioned and just be based on a simple set of heuristics. Lua is now vendored in. It's always there. Previous versions of Suricata, it was an optional component. Suricata as a library is something that, that was officially supported with this release. Suricata as a library is important in some deployment scenarios where there's already a packet passing infrastructure, like maybe a big switch or something where they already are handling packets and they just want to give it to Suricata and say, should I be concerned about this packet? That process is now officially supported in Suricata 8. We have several vendors who are using it. Some are household names that you already know, but I don't know if I can say those here. We added something called transactional rules. If you have ever seen a Suricata rule database, you know there could be 70,000 rules. And we've given the rule writers a way to reduce the number of rules if they need to. So transactional rule means we can now express bidirectional logic. And what that means in simple terms, if I have a rule that should only fire if there was an HTTP request that looked like this and a response that looked like that, you can embody that in one rule. Suricata will combine them, and then you can alert based on that. So you don't have to have two rules, one that might set some state if this happens on a request, and one that says if that state is set and it's a response, then I do this. You can now put it in one rule, which is a very natural way of expressing it. Detections upgrade, I'll talk about that in more detail, but we've added 107 new rule keywords that you can use to generate an alert. More new features. I'm going to skip over some of these, but I will also talk about these later on. Data sets are a concept that Suricata uses to manage lists of things. So lists of bad IPs, lists of good IPs, lists of suspicious DNS domains, whatever's important to you. can be expressed in what's called a data set. So it's just a big list. That list can be dynamic, so you can add to it and delete from it, and Suricata will happily use it in part of the rule language, because most of the rules are something, something. Is it in the data set? Is it absent from the data set? Or maybe I found something that I want to add to a data set. Now we support contextual data sets, which are basically annotations for everything. So you can imagine an IP address with some JSON context. Like, what campaign did I notice this in? When did I first see it? What is my confidence that this is something bad? And all that information makes its way into the alert. So the incident responder who has that immediately available and has greater context for what's going on. Talked about the firewall. It's a new mode, but like I said, it can be combined with Suricata's inline protection. When I talked about 200 gigabit machines, I saw a couple of you shake your heads. Yeah, it's really hard to do that. And the reason it's hard is everything has to line up perfectly. You have to have the hardware that supports it. You have to lay out and use your CPU resources effectively in your memory there. Because if you take a 200 gigabit per second and do the math, you have almost no time to do any packet inspection. So everything has to work well. CPU affinity is a key part of that, is lining up the worker threads within Suricata on CPU resources so that they're close to the memory where the packet is being delivered by the NIC. We've made that, we've given you a way to make that automatic. You can still do it by hand, but you can also do it automatic, and Suricata will inspect the hardware and then make a layout and then run with that and use that at runtime. Performance is improved everywhere. As we go along, performance is always first and foremost in our minds. Security is topmost, functionality, but performance is right up there. Statistics and output, I'll talk about that in a little bit. Security, libHTTP is the thing that was converted. That's the HTTP parsing library. That's pure Rust now. It's built in. It used to be a dependency and a repository that we control, but now it's vendored into the main Suricata code, and so it's a much tighter fit. It's also hardened considerably, and like I said, that was driven by a community member from Canada. FTP, the application layer protocol, is being converted to Rust. It's a work in progress, but a lot of the foundational pieces were. ENIP, does anybody know what ENIP is?
OT, ICS.
Yep. There you go. ENIP stands for Ethernet over IP. Go figure, but it's important in some ICS environments. And then our MIME parsing, I'm sure most of you know what that is. Again, parsing, Rust, they go together. We now do it there. Talked about the new protocols. Of this list, I mentioned there are protocols where we do detection and logging, and there are those where we do logging only. The ones on here that are logging only are ARP and POP3. We tend to see some ARP traffic, and it's usually not so important from a security perspective. That's why it's just logging only at this point, but that doesn't mean we won't be doing detection on it later. And then POP3, I guess it's still used. A lot of things are still used that are old, but POP3 is logging only. The rest are both detection. SDP, I had no idea what it was beforehand. SDP is a session description protocol. It's used with SIP. I didn't know that there was a separate protocol for that. Okay, so back to Lua. We hope this is a game changer for our rule writers because it gives them a way to pragmatically express whatever their intent is. And so if there's a Suricata alert listed on another page, but Suricata basically processes things from left to right. And if any place in that step says, no, this is not something that we need to be concerned about, processing stops and it goes on to the next rule. We make that available and embody that in Lua by giving them a match function, and all I have to do is say yes or no. And if it matches, then we keep processing the rule and see if it triggers an alert. If they say no, that means I'm not concerned about this, Suricata will say, okay, it will terminate that rule for evaluation and go on to the next rule. It's always there, so now rule writers can depend on it. And like I said before, for security considerations, we run it in a sandbox environment where we watch how much resource it uses, not only machine resource, but also time. So Suricata as a library is something that's been requested by a lot of our community. And it's essentially that first line there. Bring your own packets and threads to Suricata, and somewhere in your workflow, just say, Suricata, what do you think about this packet? And it will apply the rules. Suricata, as it inspects packets, it will do TCP reassembly if it's TCP. So any stream-based protocol, it will completely handle. It knows how to decode UDP, tunnels, all that kind of stuff. So it will take that packet, do all of its stuff, and then apply any rules to it that are relevant. So if you have an infrastructure like some big Cisco switch, Cisco is not the customer I was referring to before. They could embed this in. They could use Suricata and take advantage of everything that goes along with it. We have examples of how to do Suricata as a library on our GitHub. So if you download our repo, go to the examples directory. There's a lot of examples, not only for using Suricata as a library, but doing Suricata with plugins. And plugins are a way to extend the functionality of Suricata. Application layer protocols are one of those things that can be extended. And that's also where we have this example of how to do it. So you can dynamically extend Suricata with application protocol parsers. You can do it with loggers and output. So if you don't want Suricata alerts going to our native file format, which is a file on the local machine, and you want to send it to Redis or who knows what, Kafka, whatever, you can write a plugin to accept that input and then send it off. It can be threaded, so it could be thread aware and operate independently of anything else, or you can have it not support threads and have it be single threaded. I recommend being threaded and supporting concurrent access. And you can also add new rule keywords if you wanted to do that. So if you're in an environment where things are sensitive or you have a protocol that no one else understands but you do, you can write a protocol parser. You could add your own rule keywords for that and manage it completely on your own. Take Suricata, build your stuff, deploy it, and Suricata will load and make use of those. This is an example of the transactional rule that I mentioned before. So this rule will look at an HTTP request. So file data would be the data contained within a request. Say it's a post. The file portion of that, Suricata will evaluate and look, in this case, content 123. Low value rule here, content 123 is not very good, but there can be a lot more stuff that you would put in there. So that's the HTTP request part of it. The HTTP stack code is the response. So if I saw a request with this data and a response with that, then I will generate an alert. Fast pattern, I see it has a typo, is a way of telling Suricata to take the content that it sees in this rule and store it in our multi-pattern matcher library. That's the thing that lets Suricata run at scale and run fast. We use something called hyperscan. We say, here's a rule at startup, give it all the rules, and then we say, here's the data that I'm working with. Tell me the rules that apply to this data. And so that usually takes that 70,000 number that I mentioned and it turns it into a number more like 3 or 7 or 9, some very small number. So you can think of Suricata as a very advanced work avoidance software, but that's the way it runs at scale, is by using this multi-pattern matcher, and fast pattern is part of that. In in the past, a lot of folks have complained, hey, I get all this rich logging data. It's great. Logging data is used for forensic, NSM. Suricata does that really well. But like, I want to be able to write a rule that uses some of this. And this example shows FTP reply in the rule. So we've always logged all the information we know about an FTP session. including replies, responses, you name it. And they're like, well, we want to write a rule on that. So this, again, is a very low-value rule, but it demonstrates FTP.reply is one of these things that was requested but from the folks over at ET, Proofpoint, who are some of the main rule writers for Suricata. And this says, if you see FTP traffic with a reply that contains, please specify the password, then generate an alert. Again, real low value, and if you've ever used FTP, you know this is a part of every normal FTP transaction. But the point is, we took on the motto, if you can log it, you should be able to detect on it. We added 107 new keywords, under that umbrella. We have more work to do, but we've made a healthy start at in this release. We've also, this is just more of the same. These are things that were logged only, the TCP, the window scale, the Postgres query, MDNS is multicast DNS, TLS.ALPN. Honestly, I don't know what that is. I don't know what ALPN is, but, and then WebSockets. Entropy is a new keyword that was added. A year ago at Suricon, somebody talked about how they were doing this with Lua. And we decided, hey, if it's important and you can do it in Lua, then maybe it should be part of Suricata. So it was made into a rule keyword. It's implemented in Rust. If you know what entropy is and how it applies to network data, you'll know that high entropy data often, but not always, often corresponds to malicious content. So you can write a rule that says, hey, if it's a portable executable and the payload has a high entropy, then I want to know about it, because maybe it is something that I should be aware of. Contextual data sets. This is the type of context that you can get into your alert stream to make it more efficient for an incident responder who is getting volumes of alerts and has to go through it. This is some example, but you can, like I said, you can include security campaigns. When did I first see this? Where did I first see this? What is my confidence that this is really there? And you can annotate your data set with that. You can dynamically adjust the contents of it. And then Suricata will include that in the alert when that alert triggers, so you can know that here is some research that's already, or here is some investigation that's already been done. I put it in my data set for a reason. This is the reason why it was in the data set, and now I'm seeing it. So I talked about firewall mode. I want to come back to it. You can tell we're a little bit proud of that. It was a significant effort, but it extends the ways that you can deploy Suricata. Without firewall mode, if you take that line out, Suricata, it can be deployed in passive mode, where it receives a copy of everything that's traversing the network for visibility and inspection, and it gives you alerts. You can put it in inline mode, so it's a bump in the wire. Suricata will take stuff from one side, do its inspection, drop or allow packets to proceed to the other side, and so forth, and do that bidirectionally. You can also add to those modes NSM, which is network security monitoring. You can just have Suricata generate rich metadata for you, and it does a really good job at that. But you can combine it with prevention, inline or active. A lot of folks didn't know this, so I'm mentioning it. Suricata can also be a full PCAP capture device. If you do that, pay attention to everything, including how you're storing this stuff, because it should be really quick. Suricata depends on low latency operation throughout. Eric LeBlond, who I mentioned before, Stamus Networks, #1 on all those lists. Eric contributed something called conditional PCAP capture, which I think a lot of folks can make use of. And that says, if there is an alert, generate a PCAP. So for things that I told you that I'm really concerned with, when an alert happens, I also want the network data associated with that alert. And Suricata will take all the alert data that it has, include it in the PCAP file, so you can do forensics. So you're going from full PCAP capture down to something like, hey, an alert happened, and here's the packets at your disposal, and you can incorporate those into your workflows.
So you're using a buffer of like a ring buffer of some sort, and then you have the ability to look back based on time or amount of flows, or
So it's
cell
Yeah, so it's done based on the stream. So if an alert happens and it's a TCP connection or even UDP connection, whether it's HTTP or whatnot, whatever we have at that point, we will dump. Note that Suricata keeps a sliding window. It doesn't keep everything. It keeps a sliding window. But that's enough to give you the rich context that actually triggered the alert. You have all the IP information. You have how many bytes traveled this way and that way, how many packets traveled in each direction. And by the way, here's the thing that triggered the alert. So you get some context, and you can adjust the size of that window. There's ways that you can do that, so you can make it as big or use the default. If it's the default and it's a reasonable size connection, you'll get it. If it's a long-lived SMB connection, these things can live for days or weeks. You're going to get the sliding window. So you will get something.
That's very helpful. I've got a cluster running 350 gigabit per second, and we're having to, so you can imagine the volume of that. So we're having to pipe that data out somewhere else to do cell cap at 350 gigabit per second. So the ability to drag that out of 8 at that spot instead of doing a duplication or like basically a rip of stenographer, that's a big damn deal.
Okay. Well, I'm glad it can be helpful, and we can talk more about some of the details of that. But yeah, that's one of the reasons why it was there, to give you greater context, so that you can apply some focus to what you're doing.
Thank you.
Welcome. Auto pinning, I talked a little bit before about why it's really important. There's two ways you can do auto pinning. One is you can say, hey, here's a network interface, and Suricata will interrogate the system, find out what NUMA node it's on, if it's a multi-CPU socket node, and then it will give preference to that NUMA node to try and keep the workers closer to it. NUMA node is a way of organizing a system so that the memory is closer to one NUMA node than it is to the other NUMA node, so there's less latency when accessing the memory associated with the packets that arrive from that. So we can do it at the interface level, the NIC, or we can just apply it on the system depending on what it is. I found even with the fastest traffic rates, Suricata's latency to accessing the packet is less demanding than the NIC being able to transfer the data to the same NUMA node that which it's attached. Suricata can normally tolerate it, the NIC can't. It will start dribbling packets out. So for that, we also have this. Just tell Suricata where it is. It will look at everything and make what are usually pretty solid resource decisions on how the workers are laid down. Performance, the only thing I'm going to talk about in this list, performance is better everywhere, but the rule loading and initialization are really important, because if there were Suricata running in your environment and then something happens and it's terminated either abnormally or administrative reasons or just through some software errors, depending on how you're managing your workloads, Suricata restarts, and that latency between the time that it's down to the time that's up, you're exposed for that. Suricata 7 and earlier, it's about 1.5 minutes if you have 70,000 rules. Suricata 8, it can now be a few seconds, literally a few seconds. And the first time I saw this firsthand, I'm like, oh, something's wrong. I set it up wrong. So I did it again, and I'm like, oh, yeah, we have this now. So Suricata will cache information that it builds while processing the rules. So that 1.5 minutes also includes caching time. The next time it starts, it will use those caches to its advantage to reduce the startup time. And so in importance where visibility is important, you have to have it constant, that's important. Output statistics, we have better statistics, so better telemetry throughout. It's more focused. It's meant to help the person understand what's going on operationally. And output is what I talked about, the metadata and stuff. So I'm running out of time, and I have some more things to go. So I'm going to stop with this page and then have some time for questions. Suricata.io, again, that should be your landing spot. That will get you everywhere. you need to get in the Suricata world. So we have a active forum based on discourse where team members like myself and others and other community members will respond to questions. It's always helpful to give as much information as you can when posting a question so we don't have to do a little bit back and forth. We have some guidelines, so if you do a new post, it will say, please include these things. We have a vibrant community, and sometimes the community will give the response before that we do, but we do look at that regularly. We also use Discord. I personally don't use it as much as other folks use it. Discord is more of an interactive chat-based, and it becomes a little bit harder to manage, but we do regularly monitor that. The third link there, I included that because that's something that a member of our community put up by themselves. We didn't ask them to. They called it the awesome Suricata list. That is from Sasha. He's a German citizen. He decided, hey, I use it, I contribute to it, I really wanted to put this list together. So that's a great list to look at. And then, so there's our forum. Those are a couple of a couple of links for Suricata 8 being released. Talked about the community. One thing I haven't mentioned is every year we do a Suricata users conference. It's called Suricon. This year it is in Montreal. And I will be asking a question once I think of what it is for passing out a code so you can attend it virtually. It will be happening on November 19th, 20th, and 21st. It's every day is long, a lot of presentations, not only from OISF staff, but also from members of the community talking about different ways that you use Suricata, different things that they've done, and so forth. So like I said, we'll be giving out one code for that, and we'll hook you up and make sure that you get that before it gets close. I'll leave this up while I ask if there's any questions.
Can I just make a
Yeah.
additional?
Kelly Masada is the president of the OISF.
Just for more resources, we just posted 3 new videos on our YouTube channel, all covering Suricata 8. So from Victor Julian to Peter Menev, so you get to see sort of Suricata 8 from a couple of different perspectives if you want to check it out. But the YouTube channel is being populated with a lot of great content.
Yeah. So questions?
This may be captured in one of the links you provided, but just curious, what would you suggest as the lightest or smallest and cheapest employment of Suricata for monitoring 50 to 70 endpoints over a gigabit connection for home, classroom, a small team?
Yeah, so most of you guys know what a Raspberry Pi is. Pi 4, Pi 5 can be great at that. Suricata will run on ARM platforms, and if you can get the network hooked up and figure out the storage, that could be just fine. I had one in my house, and it was running both Zeek and Suricata to get some visibility into what was going on in my home network. So small number of connections, never more than a couple gigabits per second. Well, never more than a gigabit per second. And it did just fine. The reason I'm not running it is the maintenance for the logs. I didn't have that set up, and so it kept filling up and stopping. But a Raspberry Pi can be useful, or any low-end, some sort of NUC can be possible, just using the onboard, network, or maybe some wireless thing that you have. The key is how do you get at the traffic in a small environment through a tap or a span is something that you would have to figure out how to do. And there are low-cost options for doing that. You can do it with a single CPU socket, maybe 8 or 16 cores, healthy amount of RAM, and a fast, an SSD at least. Yeah. There you go. Any other questions? Oh, yeah, okay, sorry. Suricata. Suricata does it, so it's all custom. Yeah. We have a lot of information online, and then you can use our forums to ask some, specific questions. So, what? Yes, thanks. All right. So, does anybody remember when Suricata started? I mentioned a couple of years. 2010. That's really good. Here you go. She looked quite capable of catching it. All right. Suricata's technical lead. I mentioned the name once.
What other OT support is in place other than ENIP? I have forgotten. If you're doing DNP3, Modbus.
DNP3, yes. Modbus, yes. And frankly, there's not the support for things like that. Usually come from outside the community when there's a specific need. So we do have Modbus and DNP3 and ENIP. There are not a lot of rules that detect on those. So those would be rules that you would have to develop in-house, most likely.
Okay.
Yeah.
I definitely want to talk more, especially if you're going to be in Montreal.
Okay, yes, I will be.
Patrick's going for speakers.
Oh, yes. Okay, awesome.
I'm doing a lot of OT work with Zeke, but I've obviously loved the Suricata community because of what the community is. So maybe there's some ways I can port some of that stuff over.
Okay. Yeah, we can definitely talk.
Okay, cool.
All right, Suricata technical lead, anybody?
CTO was Eric?
Oh, close, close. Yeah.
Well, you're gonna get that.
Yeah. Eric is great. Right here with the hat. All right. Yeah. All right. Who said that?
I did.
Oh, you said Victor Julian. Okay. All right. Gosh, questions for the ticket.
Who wants virtual ticket to Suricata?
Yeah. Yeah. Who wants to and will attend and use a virtual pass for Suricon? 3 days. There you go. November 19th, 20th, and 21st. Yeah? Okay. She'll hook you up. All right. All right. Okay. And who learned something about Suricata today? Yeah. Oh, wow. Okay. All right. So pick a number between 1 and 10. 7. Did you say 7? Yep, that's the number I was thinking of. Here you go. Can you pass that over to her? All right. I don't want to throw it. All right. I'm going to leave some stickers up here, but go ahead. You got a question?
I have a question. Please don't throw anything at me.
I won't.
Can you extend the Suricata rule packs with your own custom rules?
Yeah, absolutely. So not only can you use, I mentioned ET, which is emerging threats. They were involved very early in Suricata's days and actually brought Kelly into the OISF role. Now they're owned by Proofpoint. So they are the main supplier of paid and free. They have a free rule set called ET Open. They have a paid one called ET Pro. I don't know what the cost involved is. They have a web page and you can look it up. A lot of folks just use ET Open. Suricata recognizes that you may have rules from multiple sources. You may use ET Open, and then you may have your own curated rules or your own self-developed rules. And so within the Suricata configuration, you can tell it what those files are. So you can say, hey, here's the rule file, and by the way, also load my proprietary rules, and so forth. And it will handle all of that.
You see a lot of usage through like OpenSense firewalls and such.
Yeah, OpenSense and pfSense are very important partners for us. We've worked closely with them for a long time now. OpenSense in particular is a huge supporter of Suricata. Are they a consortium member?
No, they've been our lead sponsor for Suricon for 3 years in a row now.
Yeah,
They're very predominant in our community.
yeah. They're
OpenSense.
OpenSense and also pfSense. OpenSense is more directly involved. I'm going to leave some stickers and up here and the journal books because I am out of time. But thank you all for attending. I appreciate it.